our next theorem is going to be the extendability theorem. So extendability. And we'll call it theorem 0.011 in sticking with our naming convention. One thing to note about this theorem was it was actually originally an axiom, the way that Euclid had his elements written, but we replaced this axiom with the ruler axiom, and we can use the ruler axiom to prove this. So you could have done this either way. So the theorem says, so THM for theorem, my writing's a little bit messy, but oh well. It says, if A and B are 2 points, so if A and B are 2 points, then the segment AB can be extended on either end by a positive distance. So how are we going to prove that? Well, let's start. So we'll say let A and B, so let A and B be 2 points, and we'll let F of AB, F of the line AB to the real numbers, be a ruler for AB. And once again, that's the line AB. Then we'll assume that F of A is less than F of B. And you could do this for either direction. You just have to assume that they're not the same 2 points. Could have done that a little bit differently, but this is the way we're doing it. Then we'll say let epsilon equal 0, or let epsilon be greater than 0. We do need a positive number here, and the epsilon can be as big or as small as you want it, as long as it's bigger than 0. So that we have epsilon to 0, greater than 0, we'll define a point C by C equals f to the negative 1, so f inverse of f of r, or f of b, sorry, couldn't read my notes there for a second, plus epsilon. Then f of c equals f of b plus epsilon. Alright, so far, so we have f of a is less than f of b, less than f of c, so we have b is between a and c, which is denoted a dash b dash c. Then BC is equal to f of c minus f of b. That's just by an earlier definition, which that's equal to f of b plus epsilon minus f of b. So we're just saying that the distance from c to b is epsilon, which is equal to the absolute value of epsilon. But epsilon is greater than 0, so that equals epsilon. And that'll be the end of the proof. So just a little note, so we have extended distance of segment AB by the distance epsilon. So whatever distance we want to extend that by, just to let epsilon be that number, and we can then extend our line.